So, hi children. So, in that previous video we discussed up to properties of perfect squares. Only 3 points we discussed. No. So, next leftover points we will discuss in this video. So, let us see that next point. Here, square of an even. Sorry, even already completed. No. So, square of an odd number is always odd. Is always odd. Already we discussed about that even numbers. Okay. So see here, square of an odd number is always odd. So here let us take that 3. So its square is equals to 3. 3 is 9 only, no. So 3 is an odd number and its square is also an odd number, no. Okay. So 3 is an odd number and 9 is also an odd number. So let us take that as 7. 7 square is equals to 49. 7 sevens 49. So 7 is an odd number as well as 49 is also an odd number. So the square of an odd number is always odd. The square of an odd number is always odd. Okay. So square of an even number is always even. Square of that odd numbers is always odd. So this is that another property. So next property say that. Next one is square of an improper fraction. Square of an improper fraction. So next property say that square of a proper fraction, square of a proper fraction is always less than the fraction, or less than, or is always smaller. Also we can say that is always smaller than the fraction. Okay, here less than means that is lesser. Okay, lesser or smaller. So what is the meaning of this one? Square of a proper fraction, square of a proper fraction is always lesser or smaller than the given fraction. Okay, so smaller the fraction. So what is the meaning of this one? For example, here 2 by 3 is there. 2 by 3 is a proper fraction, yes or no? Actually, what about that proper fraction? In a fraction, the numerator is less than its denominator, then we will call that fraction as proper fraction. Now here, square of that proper fraction, square of that proper fraction, what you will get here? So 2 by 3 whole square meaning is what? 2 by 3 is multiplied itself by 2 times. Okay, so 2 by 3 into 2 by 3. So which is equals to 2 into 2 is equals to 4, 3 into 3 is equals to 9. So 4 by 9. Clear? Now here how we can say that these two numbers, how we can compare that? We have that comparison also, two methods there, no? First one is by taking that equivalent fractions like that, or another one is here which fraction we taken, that is 2 by 3, and here which fraction we got after square, that is 4 by 9. Okay, now take that cross multiplication here. Here 2 into 9 and here 3 into 4. 2 into 9, 3 into 4. So 2 by 9 is what here? 2 into 9 is equals to 18 and 3 into 4 is equals to 12. So 18 is greater than 12 or not? 18 is greater than 12. That's why here 2 by 3 is greater than 4 by 9. So that's what I said, that the square of a proper fraction is always less than the given fraction, is always less than that given fraction, or is always smaller than that given fraction. Not only this one, you can take that any proper fraction and you can check that. Okay, if you take the decimal values also, you can check that one variation. Okay, so this is that next point. Let us see that next one. So next point is number of non-square numbers, number of non-square numbers, number of non-square numbers lie in between any two consecutive squares, any two consecutive squares, let n square and n plus 1 square is 2n. So this is that another property. What is that property here? Number of non-square numbers lie in between any two consecutive perfect squares. Okay, any two consecutive perfect squares means here n and n plus 1 consecutive numbers, no, 1 and 1 plus 1 2. Okay, those two are consecutive, so 1 square and 2 square. So in between 1 square and 2 square, how many non-square numbers are lies in between 1 square and 2 square? Okay, so that one, how to know that? So here 1 square is equals to 1, 2 square is equals to 4. 1 square is equals to 1, 2 square is equals to 4. Okay, so here how many numbers, non-square numbers means what here? In between 1 and 2 we have here 2 and 3. Yes or no? In between 1 and 4 we have here 2 and 3. Okay, so we will call that 2 and 3 are non-square numbers. Which numbers those are? Non-squares, non-square numbers. So 2 is not a square number. 2, its square is 4, but 2 is not a square. Okay, 2, its square is 4, but 2 is not a square. 2 is called square root, that one we will tell later. Okay, so here 2, 3 are non-squares. Not only these two, we have some other also. Next 3 square. So 3 square is equals to 9. So in between 4 and 9. Okay, how many numbers are there? 5, 6, 7, 8 and 5, 6, 7, 8. Here we have that 4 numbers are there. These 4 also non-squares only. Okay, so the numbers which lies in between any two squares, those numbers we will call them as non-square numbers. Okay, now how to find that number of non-square numbers lies in between any two perfect squares? Let us see that here 2 non-squares there, here 4 non-squares there, next one maybe 9 non-squares will come. Okay, how to know that? Here we have to know, we have that one of the formula, that is 2 into n. 2 into n. So what about the 2 into n? Let us see that here, if you want to find that a number of non-squares lies in between 1 square and 2 square. Okay, so here n is equals to 1, n plus 1 is equals to 2. Yes or no? Consecutive numbers n and n plus 1. So in between these two numbers, here what is that formula? That is 2n. What is that formula? That is 2 into n. So n is equals to what here? 1. So substitute that 1 here. So 2 into 1 is equals to 2. So how many non-square numbers lies in between 1 square and 2 square? That is 2 numbers are there. 2 non-squares are lies between 1 square and 2 square. Is it clear? Okay, I'll give you one other example also. See here, 6 square, 7 square. Number of non-square numbers lies in between 6 square and 7 square. 6 square is 36, 7 square is 49. So in between how many non-square numbers are there? In between. Okay, in between means you should not count these two. Okay, you have to calculate these numbers only. How many numbers are there? Those are called non-square numbers. No, here. Okay, how many non-square numbers are there here? Just again, this is n and this is n plus 1. Yes or no? This is n and this is n plus 1. This is 6 and this is 6 plus 1 is equals to 7. 6 and 6 plus 1 is equals to 7. Okay, so here n is equals to 36, n plus 1 is equals to 49. So what we have to find out? Here you have to take that this is 6, you have to consider it. Okay, don't take that it's a square value. Here you have to take that which number we taken for its square. Okay, that one only you have to consider. So this is that n. Okay, this is that n value. So here 2n. So we can take that 2 into 6 is equals to 12. So 12 non-square numbers lies in between 6 square and 7 square. Okay, why we should not take that one as 36 and 49? Here this is n and this is n plus 1. I am saying no. Here this is the n plus 1 value. This is. Okay. This is that n, that is not n plus 1, that is n plus 1 value, and this is n value, not n. Okay, that is n value. Here n is 6 square. So 6 square n value, that is equals to 36 I am saying. And here 7 square is n plus 1 value is 7. So n plus 1 square is equals to 49. Okay, that is the meaning of that one here, n and n plus 1. For your understanding only I written here. Okay, so this is not n and n plus 1. Here these two numbers you have to consider it as n and n plus 1. Okay, so here how many non-square numbers lies in between n and n plus 1 whole square? N square and n plus 1 whole square. How many numbers are there here? 12 numbers. 12 non-square numbers lies in between 6 square and 7 square. Is it clear? So this is about this point. So in this video, how many points we discussed here? 3 points. What are those once again? Square of an odd number. Square of an odd number is always odd. Okay. Next, which one we discussed here? Next one is square of that proper fraction is always smaller than that given fraction. Okay. Next one is number of non-square numbers lies in between any two consecutive squares. Any two consecutive squares. Okay. Again here in that definition I am saying two consecutive squares. Two consecutive squares is 2n. Okay, so totally how many properties we have? We have that 6 properties in all. So in this video we discussed that these 3 points. In that previous video, what are those 3 points once again? Here a perfect square never ends in 2, 3, 7, 8. If that number is ends with, okay, or if the number is having either 2 or 3 or 7 or 8 in its units place, then we can say that that is not a perfect square. That is the first point. And the second one, what is that? A perfect square should ends with even number of zeros. Okay, if that number, if that is a perfect square, then it should be ends with even number of zeros. If that odd number of zeros there means easily we can say that that is not a perfect square. Next, come to the last point. I mean in that video last point, that is the square of even number is always even. So these 6 properties also very important. Okay, so after this one we are going to discuss about that square root. Okay, so here square root as well as in the same concept we have that Pythagorean triplets also, but I will tell you that Pythagorean triplets after that square roots. Okay, why? Because means that one also I will tell you that. Okay, in that next video we will discuss that one. Okay.